Hi everyone, welcome to another mathematics class with Zara. Today our topic is sort. What are sorts? Sorts are numbers whose square roots are irrational numbers. Irrational numbers are numbers that are indefinite. For example, you have the square root of 4 to be 2. This is a rational number. So it is just an integer or a simple fraction. So those are rational numbers. But a situation where you are having the square root of 5, which is 2.23606 dot. This is an irrational number. You can write it in two decimal places as 2.24. This number is correct as the square root of 5, but it is not an accurate value because 2.23606 to infinity is the correct and accurate value for the root of 5. Let's take examples where to simplify the square root of 60. In this case, we can use two methods. We can use the LCM method or the factors method. Now finding the LCM of 60, 2 in 60 will give you 30, 2 in 30, 15, 3 in 15 will give you 5, 5 in 5, 1. In this case, this 60 can also be written as 2 times 2 times 3 times 5. So if you are to simplify the square root of 60, we have it as 2 times 2 times 3 times 5. In this case, 2 times 2 is the same thing as 2 raised to the power of 2 times 3 times 5. 3 is only 1, 5 is only 1. So you cannot write their square in that form. So it is raised to power 1. So now this will also be written as 2 raised to the power of 2 times square root of 3 times square root of 5. Here the square root will cancel the square. We are left to 2 times root 3 times 5, which is 15, to give us 2 root 15. 60 can be rewritten as 2 times 30. 60 can also be written as 4 times 15. 60 can be written as 3 times 20. 60 can be written as 6 times 3. You will discover that this particular one is having a perfect square. That is, a perfect square is a number that by the time you find their square root, it gives you a whole number. So here you discover that 4 is a perfect square. So we'll be picking this such that you'll be able to find the square root of one of it, then the rest will be left in the square root. So now 60 becomes root 4 times 15, which is the same thing as root 4 times root 15. Square root of 4 is 2 root 15, just like the previous method you use. So whichever method you find easier, you work with. Now using the LCM method, 72. 2 in 72 is 36. 2 in 36 is 18. 2 in 18 is 9. 3 in 9, 3. 3 in 3, 1. So now 72 is the same as 2 times 2 times 2 times 3 times 3. So now let's simplify. This becomes 2 times 2 times 2 times 3 times 3. In this case, this can be rewritten as 2 raised to the power of 2 times 2 times 3 raised to the power of 2. So now by the time you have it this way, 2 raised to the power of 2 times 2 square root of 2 times this. This square, we cancel out the square root. This square, cancel out the square root. We are left with 2 times root 2 times 3. 2 times 3 is 6 root 2. So to simplify it with 72, we have it as 6 root 2. Also, 72 is the same as 2 times 36. 72 is the same as 3 times 24. 72 is the same thing as 4 times 18. 72 is the same as 6 times 12. 72 is the same as 8 times 9. You will discover, just like we solved the other way, you will discover that 36 is a perfect square, because we find the square root of 36, we'll be getting 6. Also, 9 is a perfect square. You find the square root of 9, you'll be getting 3. So that means we can use this, we can use this, using the second method I explained earlier. Likewise, this 4 is a perfect square. So you can use any of these three for that method. Root 72 can be rewritten as 2 times 36. 36 is a perfect square, remember, to give us root 2 times root 36. Root 2 times root 36 is 6. So it becomes 6 root 2. Also, if we are using this becomes 4 times 18. If you look at 18, you can simplify it further to give you 2 times 9. So here it will be 4 times 2 times 9. 9 is also a perfect square. So 4 is a perfect square. So it becomes root 4 times root 2 times root 9. To give us square root of 4 is 2 times root 2 times square root of 9 is 3. 2 times 3 is 6 root 2. You can use this to also solve for this. In a situation whereby you have 2 root 15 as a simplified surd, how do you take it back to a single surd? In this case, you find the square of the coefficient. This 2 root 15 is like saying 2 times root 15. Now, for this coefficient to have a square root, you have to find the square. So now this becomes root 2 squared times root 15 to give us what? 4 in the square root times 15, which is 4 times 15 to give us square root of 60. A simplified surd back to a single surd. If we have 3 root 5, for example, we want to take it back to a single surd, you find the square of the coefficient, which is, you put it under the square root, which is what? 3 square. I told you earlier is like saying times root 5. So this becomes what? 9 times root 5, which is 9 times 5. Give us what? The square root of 45. So the square root of 45 simplified will give you 3 root 5. So this is a single surd, this is a simplified form. Addition and subtraction of surds. Before you can add or subtract surds, they must have the same radicals. That is, the numbers underneath the square root must be the same before you can add or subtract. If you have 2 root 5 adding 3 root 2, this cannot be added because this number underneath the square root is not the same as this number. So in this case, this is a final answer. But if you have 2 root 5 plus 3 root 5, this case, the radicals are the same. That is, the number underneath the square root are the same. So this you can simplify further by adding up the coefficients. So in this case, you add up 2 plus 3. The root 5 stands as 1. So you write it once. So this becomes 5 root 5. So adding up this will give you 5 root 5. It's just like saying 2x plus 3x in algebra. Then you are not going to be writing the x twice. It is once. So this 2x plus 3x is giving us 5x in algebra, but here, because this is surd, it becomes 5 root 5. Another example, we are asked to simplify 6 root 28 minus 3 root 7. This can be simplified further. 28, you can use any of the methods. Let's use the factor method or multiple method. In this case, this is 2 times 14. 28 is also 4 times 7. 7 times 4, 14 times 2. So in this case, you discover that this is having a perfect square, which is 4. So here, we will simplify this 28 further, as this becomes 6 root 28 is 4 times 7 minus 3 root 7. This is an entity, this is an entity. So here, to simplify it further, it becomes 6 times 4 times 7 minus 3 root 7. Root 7 minus 3 root 7. So to subtract now, you subtract the coefficients, you leave the surd. So 12 minus 3 is 9 root 7. Simplify root 90 plus root 64 minus root 40. In this case, like we have been doing earlier, you find the number that is a perfect square such that you be multiplying it here. So 90 here is 9 times 10, because 9 is a perfect square. So 90 is 9 times 10. 40 here will be 4 times 10. 4 is a perfect square. So here 90 becomes root 9 times 10 plus square root of 64. 64 is a perfect square itself. So square root of 64 is 8 minus root 4 times 10. So here 9 is a perfect square. The square root of 9 is 3. So we have 3 root 10 plus 8 minus 2 root 10. In this case, we are going to be collecting the like times. That is 3 root 10 minus 2 root 10 plus 8. 8 is not having any root, so it is standing separately. So 3 root 10 minus 2 root 10, like we did in the other examples of the subtraction, you subtract the coefficient, because this 10 root 10 will pick 1 to represent it. So 3 minus 2 will give us 1 root 10 plus 8. 1 root 10 is the same thing as root 10 plus 8. Or you say 8 plus root 10. Root m multiplying root n. Both are underneath the square root. So you solve it as m times n under the square root. Also, if you have m dividing with n, both you solve this way, m over n. Also, if you have root m multiplying root m, it becomes m. In a situation whereby the coefficients are greater than 1, the fourth law is applicable. If you have a root m, the coefficient is greater than 1, so we are representing it with a times b root n. In this case, you multiply out the coefficient and multiply the radicals too. That is a times b root m times n to give us a b root m n. So likewise for the division, a root m divided by b root n. Here the coefficients are greater than 1. So this becomes a over b root m over n. Remember, when we were solving addition and subtraction, we said the numbers underneath the root must be the same before you can add or subtract. But for the multiplication and division, the numbers does not necessarily have to be the same, because when you apply the law, you are multiplying them. So it is not like addition and subtraction whereby you pick one, just like 2x plus 3x is different from saying 3x times 2x. So in this case, this coefficient is greater than 1. So we are going to be applying the first principle or law, which is 2 times 5 in bracket in the square root of 3 times 5 times this 5. 2 times 5, 3 times 5 give us 10 root 15. So 2 root 3 times 5 root 5 is 10 root 15. Another example, 4 root 15 divided by 2 root 5. In this case, you have it as applying the principle. So 4 root 15 over 2 root 5. So this becomes 4 over 2 root 15 over 5. So this 4 into will give us 2, 5 in 15 will give us 2. So this is 2 root 3. In this case, you can either say root 6 times 6, which is 36. Square root of 36 is 6. Or using the third principle that says if we have the same number underneath, then the number becomes automatically, the answer is 6. So 6, using the third principle, m with m times with m is m. So with 6 times 6 is this. So which is the same thing as what? 6 squared.